Thank you. Dr. Kwame has done a brief review on yesterday's lecture, and at this point, I believe everyone present in the group can create our measurement models and then join them together, because that is very, very important, because if you cannot create the model, then you can't run any analysis. So are we all good with the creation of the path models?
Yeah.
Oh, okay. If we are all good, then very well then. So I'm also going to launch my Smart PLS, create a workspace. For those who didn't follow through yesterday, we're able to rectify it. So I had to delete my previous project just to make this work. So I have to go all over it again. So if I create it here, I can create it there. So I'm just going to drop it somewhere else. It's on my desktop. Hold on a second. Go inside here. Oh, how come it's telling me I've created in all those folders?
I think it's forcing you to use an empty folder.
Yeah. You know, while we're testing the stuff, then I deleted all my stuff. So now I think I can. Is this folder empty? Let me create a new folder here on my desktop. Hey, it's like the screen becomes more responsive when I'm sharing. It's a struggle. Come, let me launch my PLS again. I don't know why it's freezing. Okay, I think I have this. Okay. Okay. Just want to make sure I have this. Okay. I think we all have this diagram, right? Hello, everyone.
Yes, yes, yes.
Okay, okay. Thank you. So now that we have this diagram, let me just highlight a few things before we take today's class. Now we have the structural model and the measurements model together. The next thing we want to do is, how do we analyze this model? How do we perform the analysis? Now, for us to perform the analysis, there are some conditions that we must have in mind. And those are the things we'll be going through today. And please, this is very, very important. You may not know how to run any complex analysis, but once you understand these basic conditions, you can always interpret your result reasonably. So I'm going to share my PPT now. Can you all see my PPT?
Yes.
Yes.
Okay. So today we'll be going through the assessment of the validation of the measurement model. And then we'll also look at how we assess the validity of the structural model. And if we have enough time for the day, we'll go through mediation and moderation theory. Now, for us to validate our measurement model, when we say the measurement model, yesterday I did mention that the measurement model simply means the relationship between the indicators and the construct. Now, something is very important to SEM, which is what we call unidimensionality. It's a big word, but very simple. It simply means that when you've created a construct, make sure that that construct is being measured by the underlying indicators alone. So your observed variables capturing a construct must measure that alone. And that is why the issue of instrumentation is very important. So for instance, if I'm capturing something like loyalty, every indicator under it must be psychometrically censored to capture that accurately. Now, the next thing we want to look at is reliability of our instrument, which has to do with the consistency of the scale. Meaning, if I have a questionnaire and I replicate that questionnaire to collect data under the same conditions, my results should be approximately the same, the data. If your questionnaire cannot replicate the data you've collected accurately or reasonably, then your instrument is not reliable. Now, the next one is validity, which has to do with a measure of what you really want to measure. These are theories. You understand it more when we get to the practical section. Now, it is very important for us to test for this concept of unidimensionality in structural equation modeling. And for us to do that, we have two basic ways of doing it. The first one is what we call the convergent validity. The convergent validity. Now, the convergent validity is simply telling us that how correlated are the items of the indicators? How correlated are they with the latent construct? This means that, for instance, if I went back here, if I went back to my PLSM, if COMP1, COMP2, COMP3 are designed to measure competency, we would expect a reasonable relationship between these three items and latent construct. And the rule of thumb is that when I run what we call the factor loadings, go back there, the factor loadings should be greater than 0.7. You'll see it soon, don't worry. Just keep it in mind that the factor loading should be what? Greater than greater or equal to 0.7. Now, the information in the highlighted information here is very, very important. It says indicators with outer loadings between 0.40 and 0.70 should be considered for removal only if the deletion leads to an increase in the composite reliability or average variance extracted. You understand it, don't worry, it's just grammar. Now, the next one is composite reliability, which is also known as the omega coefficient. It should also be greater than 0.7 or equal to 0.7. Just keep in mind, factor loading should be at least 0.7, composite reliability should be at least 0.7, and then the average variance extracted should be greater or equal to 0.5. Now, let's run this. These three conditions, let's see how we are going to implement them. We're under convergent validity. Please, let's all go back to our PLS software. Are we all there?
Yes.
Okay, if we are there, we are going to run our first analysis. And to do that, what's it called? If you're there on your parts analysis, go to calculate. Can you see calculate on the ribbon where my cursor is?
Yes.
CALC. Can you see it?
Yes. Yeah.
If you can see,
Yeah.
then good.
Yes.
Click on it. When you click, you see a pop-up window saying PLSM algorithm, bootstrapping, confirmatory, tetrad analysis, and so on and so forth. Click on PLSM algorithm. Have you done that?
Yes.
After clicking on it, you see another pop-up window asking us factor analysis, path analysis, principal component analysis. What we are doing is we are trying to model our path diagram. So we choose the one in the middle, path analysis. So make sure that the path is what? Checked. Is it checked?
Yes.
Yeah. Once you've done that, the rest is easy. Why is this still not dropping everywhere? Come in. The stuff's here. Okay, I get it. Now, all you have to do is to click on Start Calculation. Are you ready? Everyone, click Start Calculation. Have you all done that?
Yes.
Yeah.
Do you have an outcome? Do you have an output?
Yes.
Yeah, sure. Yes.
I want everyone to be on the same page with me, please, because this is very important to the whole concept of SEM.
No, like some of us are a bit behind. When I click the calculation, what next?
Just
After
click start. Once you click calculation, you check. Okay, let's go over it again, please. Please, I want us to take it a bit faster because we don't have a lot of time, please. So let's say I go back. Oh, I have this. Coming. I have this. Calculate. Click on PLS algorithm. It will open a new window where you see factor, path, and PCA. By default, path should be selected, but just in case it's not selected on yours, just click on path, not factor, path analysis. After that, you click start calculation. And you have a result like this. We all have this outcome, right?
Yes.
Yes. If we do, now let's explain. Remember, in my slide, I said factor loadings should be greater than 0.7. Now, what is the factor loading? These are the factor loadings. COMP1, you can see 0.853. Can you see that? CMP2 0.8.
Yes.
So these are the factor loadings. The factor loadings are the correlation between the indicators and the latent construct. And rule number 1 says the factor loading should be at least 0.7. So if we take a look at this first construct, we can see that all our factor loadings are greater than 0.7, isn't it? That means this construct here has satisfied the condition of what? Factor loading.
Correlation factor loading.
Now we go to the next one, likability. We can see that everything here is greater than 0.7, right? So the same thing. And if we take a look at customer loyalty, the same thing. Now we have a problem with quality. Now, if you take a look at indicator number, I'm coming, give me a second. Okay, let me turn it this way so I can see clearly. If you take a look at the indicators number 2, QUAL2, and you look at QUAL8, you can see that both of them are less than 0.7. That is where we need to refer to this criteria. Indicators with outer loadings between 0.40 and 0.70 should be considered for removal only if the deletion leads to an increase in composite reliability or AVE. Now, this is our composite reliability, 0.7. This is our average variance extracted. So now, before we decide to delete those two indicators, we need to look at our composite reliability and our AVE. So we go back to our PLSM result. And then now, you don't need to do anything. The results are all there for you. So on the left-hand side of the screen, you can see some result there. Graphical output, final result, path coefficient, and so on. Are you all there, please?
Yes.
If you're there, come to quality criteria. Quality criteria. If you're there, click on construct reliability and validity, like this. When you click, you will see a pop-up window saying construct reliability and validity. Now, we have two variables that did not satisfy the condition of what? 0.70 on the factor loadings. And the condition is that factor loadings between 0.4 and 0.70 should be considered for deletion only if their removal leads to an increment in the composite reliability and average variance extracted. So I want us to take note of the composite reliability, the first one, RHOA. Remember, the variable giving us the problem is what? Quality. That's where the problem is. Now, quality has a composite reliability of 0.889 and an average variance extracted of 0.544. Please note that because we are going to compare. We are going to rerun the model and compare. So, with that in mind, let's go back. Now, I want to delete the lowest factor loading here. After deletion, I'm going to repeat the calculation. If either of these two values, 0.889 and 0.544, increases, then there's a ground for me to delete that variable or that indicator. So now I'm going to delete 0.582 because that's the lowest here. So I'm going to activate my delete. Please delete yours as well. Then I click on it. Then it disappears from the model. Have you all deleted, please?
Please, we need more clarification on the quality side.
Okay.
Okay, Doc.
Sorry,
Doc,
what
could
do you
you
want?
please repeat?
Let's take it one after the other. When we are all talking, we are not going to get any information, please.
Okay, Doc, I think, is it possible for you to expand your screen? It looks smaller.
Someone was asking a question about the quality criteria. What would you like to know, please? Can you be specific?
Yes, the steps that you followed to look at the quality side. I was getting some network problems. I only heard about the quality, so I don't know the steps.
Do you on your screen, do you have the first output? After the calculation, you have it, right?
Yes, I have it.
Okay, if you have it, then what we are talking about is, I gave you some guidelines here. Here, we said composite factor loading should be greater than 0.7. Now, after running this model, look at it. If I run this model like this, can you see? You can see that the condition is that what? These are my indicators. Every one of these indicators should have at least 0.7 factor loading. But you can see that on the quality construct, the second one, QUAL2, has a factor loading of 0.678. Can you see that? And then the last one has a factor loading of what? 0.582. It means both of them are lower than the threshold value of 0.7. Now, we don't just go ahead and delete them because they are lower than 0.7. There is a sub-condition to this condition. And this is a condition here. It says, this one here. It says, I should only consider deleting those factor loadings that are between 0.4 and 0.7. I should only consider their removal only if, when I remove them, there will be an increase in the, there will be an increment in the composite reliability or the average variance extracted. So the next thing we did was to take a look at the composite reliability and the average variance extracted. And to do that, you go back to your PLSM result, which is here. And I said, on the left-hand side of the screen, you see some output there, graphical output, final result. Go to the parts with the heading quality criteria. If I click it again, you see, R square, F square, construct reliability and validity. So when you click on it, it opens up an output. And that output has what we call your Cronbach Alpha, composite reliability, RHOC. I'll explain the different between the two later. And then we have the average variance extracted. Now, the problem construct is quality. This one, Jigga. It's having 2 of 8 indicators to have loadings lower than 0.7. And so for us to consider if we are going to delete those indicators, we need to take a look at the value here, the composite reliability for the quality construct. And the composite reliability here is what? 0.889. And the average variance extracted is what? 0.544. With that in mind, you have to note these two figures somewhere. So write it somewhere because you're not going to see them again soon. After noting that, and I go back to my model. What you do is you start the deletion from the indicator with the lowest factor loading. And in this case, it is QUAL8. So now my delete button is already activated. So if I clicked on it like this, it disappears. That means I have deleted one indicator from the quality criteria. That is indicator number 8. When you delete, you see that all the values indicated on the initial output disappeared. What you have to do now is, after deletion, deactivate your delete button, go back to calculate. We are going to repeat the same process we did during the first calculation. PLSM algorithm, all the settings remain constant, then I run. Do we have a new output now?
Yes, we have.
Good. It is very important for us to follow along, please. If we have a new output, after deleting the 8 criteria, the indicator on quality, we rerun the analysis and we have a new output without the QUAL8. Now, all we have to do now is that we go back to our construct reliability and validity table. Are we there? If you went back to the construct reliability and validity table, you go back and check your composite reliability and your average variance extracted. What do you notice? Is there any change? Is there any, are they the same? What do you notice?
There's no change.
There's no change.
The
Okay, somebody said
validity
There has been a change.
There is a little bit.
A small change.
okay.
I think it changed
Reliability
from
has gone down.
0.544 to 0.58.
AVE has been changed. AVE has been changed.
Did it decrease or increase?
Increase.
Okay, please let's note that. So it means the deletion of one of them led to an increment in the average variance extracted, right? So there's an increment. And if we take a look at the first composite reliability, there was a slight decline, right?
Yes.
There's a slight decline. But it appears the second one increased. But then since there was an increase in our average variance extracted, and we want a higher average variance extracted, then that indicator is a candidate for deletion because removing it led to an increase in our average variance extracted, because the whole aim of SEM is for us to be able to explain a higher variance in the dependent variable. So now let's go back to our model again. But before then, please, let's note the new values of the AVE and the composite reliability. Note the values again, the new values. 0.885, 0.906, 0.580. Yeah, that's what we have there. So now we go back to our model again. Now let's delete the next one and see if it will also improve any of the threshold values. So I'm going to delete indicator number 2. As usual, you highlight your delete button. Smart PLS is very easy. You just click on it and it disappears. So now we are left with only 6 indicators under quality. We go back again and run the analysis. Are we all there?
Yes, we have.
Good. After running the analysis, you have a new output. Now, what we are trying to check now is that to see if there is an increment in the AVE, the composite reliability, or composite reliability after the deletion of the next construct. So we go back to our construct reliability and check. What do you notice?
Has increased.
The average variance extracted has increased, right?
Yeah,
Yes.
sure.
Yes, it
Yeah.
increased.
Yeah, so it's always best to have AVEs that are higher. So it means that it is reasonable. And sometimes these deletions are subjective in nature and there are no hard and fast rule about. Some people may choose to retain this in their model. Some may not even delete anything, but recent literature suggests that when the deletion leads to an increment in either the average variance extracted or the composite reliability, it is more appropriate to delete. But there is still academic discourse on this. As we all know, academia is non-conclusive. But this is the latest information from Hare et al. 2022. Yeah?
Hello, Doc.
Yeah?
Yes. So after the first analysis, we saw that 2 of the indicators were below 0.7 or so, if I am right. So why didn't we just delete those 2 at the instant? But we have to do them one by one, checking the composite reliability and those ones.
Because if you just delete them, first of all, deleting 2 of them at the same time may actually lead to a reduction in your AVE. So you have to check the one that is causing the problem.
So,
the rule
let's assume
okay.
that. So let's assume after the first deletion.
Okay, let me just come in here because we don't have a lot of time. Let me just come in here. Let me just state the rule, please, so that we don't waste a lot of time on this. The rule of thumb is this: in structural equation modeling, the conventional practice is delete indicators one after the other. That's just the rule, because I don't want us to like spend so much time because we have a lot to cover. But please, that is the rule of thumb, because it is more desirable to retain most of your indicators. It is most desirable because those indicators are the ones measuring your construct. So the more indicators you have, the more reliable your model is. But if there is a condition for you to delete, please delete them one after the other, starting with the one with the lowest factor loading. Don't delete all of them at the same time. But we can talk about that later after the section, please. Because we have a lot to cover, please.
All right, thank you very much.
Yeah. So now that we have this, we are progressing. Now this is our what? Factor loading. Now we go back to the PPT. So all these conditions here, they've been satisfied. All the factor loadings are greater than 0.7. The ones that weren't, we look at the criteria we deleted. The composite liabilities are greater than 0.7, as we saw there. I think so. Yeah, these are the composite reliability reports. They are all greater than 0.7 for all the indicators we can see. So it means we are good to go. Now, we go back. The next slide. This is a diagram on when and when not to delete. So the relevance of the outer loading, those are the factor loading. So any value less than 0.40 should be deleted. Now, loadings between 0.40 but less than 0.70 should be held constant for a while. Then we come in. Then those greater or equal to should be what? Retained. Now coming down to the middle ones. analyze the construct internal consistency, reliability, and convergent validity. If construct measures do not meet the recommended thresholds, delete the reflective indicators. If they do not lead to an increase in it, you delete. But if, of course, the construct measures meet the recommended thresholds or even higher, you can retain the reflective indicators. But in this case, deleting them led to an increment in the construct reliability and validity. So it is best to delete, according to literature. So now, remember I said in this slide that for us to achieve unidimensionality, we need to satisfy convergent validity. And the second one, we'll take a look at it. Please, when you're running SEM, have these three conditions in mind. Even if you don't understand anything, just go and look at your table when you run this first. Once you don't get this, then you know your data has a big problem. Very important. Now we go to the next one. The next one is what we call discriminant validity. Discriminant validity. Now, the concept of discriminant validity is simply telling us how uncorrelated the indicators of one construct should be from a construct that it's not meant to measure. Meaning, for instance, in my model, I have designed this construct to measure competency and not likability. So if COMP1, COMP2 is having a very high correlation with these or with any of the other latent constructs, then it simply means there's no discriminant validity in my data. My data is measuring the same thing. And that is not what we want. So that is the whole idea, the lame concept of discriminant validity. Oh, no. So I'm going back to my slide now. Now, under the discriminant validity, we have 4 important criteria. And the latest one is what we call the heterotrait monotrait ratio. Forget the grammar. The PLSM gives you all the values. This is the latest, and it's currently the most supposedly reliable measure. Now, the condition is that for constructs that are conceptually different, please take note. For constructs that are conceptually different, the HCMT value should be less than 0.85. Should be less than 0.85. But for construct that appears to be conceptually similar, the value should be less than 0.90. We'll take a look at that. Now, the next criteria is also very important. This one would have to do a bit of calculation. Now, the Fornell-Lacker criterion states that the square root of the average variance extracted should be greater than the interconstruct correlations. It's very easy. I'll explain it. Let me go there. I'm speaking grammar. Let me go there. I want to explain this to you with the diagram. So we are done with construct reliability and validity. So we go to the next one, discriminant validity. Please click on the discriminant validity. Are we there? If you're there, you can see the first output is the heterotrait monotrait ratio. And we said for constructs that are conceptually different, the value should be less than 0.85. But for constructs that are conceptually similar, the value should be less than 0.90. Now, if we take a look at this, this is customer loyalty, likability. You can see that this value here, they are all less than 0.85. Now, loyalty, likability, they are more of abstract constructs. They are very similar. So we can use the 0.85 criteria here. And even if we increase, some books will tell you to use 0.90 criteria for everything. You can see that all the values here are less than 0.90. So this data satisfies the condition for discriminant validity. Because even if we restrict the conditions to 0.85, majority of the values are less than 0.85, while this one is less than 0.90. Now, the interesting thing is that if your data does not satisfy the condition for HTMT, you can always consider the other two criteria. You can use any of them to validate your discriminant validity. Now, the next important one is, so you don't need to report all of them. You just choose the one that your data was able to satisfy. The next one is what we call the Fornell-Lacker criteria. The Fornell-Lacker criteria states that the square root of the average variance extracted for each of the constructs should be greater than the interconstruct correlation. I'll repeat that again. The square root of the average variance extracted for each of the constructs should be greater than the interconstruct correlation. It sounds grammatic, but it's very simple. Now let's take a look at it. Please go back to your construct reliability. Are we there? If you're there, cast your gaze on the last column, the AVE column. And those of you with a calculator, please, you can bring it out. Now you can see that for competency, the AVE is what? 0.682. For customer loyalty, the AVE is what? 0.748. For likability, it is what? 0.747. And for quality, 0.609. Please note those values, but we are going to do a simple arithmetic. So I'm going to go back to the Fornell-Lacker criterion after noting those values. Now, for competency, can someone please tell me what is the square root of 0.682? What is the square root of 0.682?
0.825.
0.825, okay?
6.
0.82, approximately 0.826, right?
Yes.
Thank you. Now, if you take a look at the first figure, the first figure there is what? 0.826. And that value is the square root of the AVE of competency. Now, what the criteria is telling me is that I'm going to compare this value, this 0.826, to all these other values here. And the condition is that this value must be greater than everything here. And we can see that 0.826 is greater than everything here, isn't it? So competency has satisfied the Fornell-Lacker criteria. You don't need to press your calculator, but I just want you to get it manually before I show you the trick. Now, let's take a look at loyalty. Customer loyalty. The AV for customer loyalty was what? 0.748. Please, what's the square root of 0.748? What is the square?
0.865.
0.865. Thank you. So if you take a look at it, you can see 0.865 is here, right? And 0.865 is greater than all the values here under it. Similarly, what is the square root of 0.747, which is the AVE for likability?
0.864.
Thank you.
0.864.
0.864, and it is lower than this. And if you take a look at that of quality, you're going to have this. Now, this is the trick. Did you notice that the diagonal elements are all the square roots of the AVEs? Did you notice that? this one here,
yeah.
this one here,
Yes,
this
yes.
one here. So it means you don't need to press your calculator. So when you have your Lacker and Fornell criterion table, the diagonal element here, 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 this, automatically they form what? The square root of the what? Average variance extracted from here. They form the square root of all these values here. So you don't need to do it manually, but I was just making you do it so that you understand the concept. So we go back there. So when I have this table, all I have to do is just to look at the first one here and compare. If it's greater, then I'm good. I'm good. I'm good. I'm good. So this data is so perfect that both the HTMT criteria, the Fornell-Lacker criteria, they are all absolutely satisfied. And you can only get this kind of result if you have done your homework when it comes to collection of data. If you see somewhere and fill the questionnaires yourself, I'll show you the trick, how your analysis will sell you out very soon. Now, the next thing is cross-loadings. Now, cross-loading is about the most incompetent criteria for discriminant validity. What cross-loading is telling us is that the indicators of a particular construct must be highly loaded on that construct and not significantly loaded on other constructs. Take, for instance, competency. COMP1, COMP2, COMP3, these three were designed to capture competency as a construct. And you can see it is highly loaded on it. 0.8, 0.8, 0.8. And if you look at the loading of COMP1 on customer loyalty is low, COMP2 on customer loyalty is low, COMP3 on customer loyalty is low, and similar for the other ones. If I pick customer loyalty criteria, 1, 2, 3, the first thing I do is to look at its loading on the construct it is designed to measure, customer loyalty, sorry, here. You can see the highest loadings are here, here, here. And it is low here, 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 here. So cross-loading is simply telling me that my indicators should be highly loaded on the construct they've been designed to measure, and then should not be significantly loaded on the construct they've not been designed to measure. So in a situation whereby you're having your indicators to be highly loaded on what you've not designed them to load on, then it means your questions were not measuring the construct you intended to measure. And that is where your instrumentation comes in. At this point, any question?
My question is,
Yeah,
to measure the discriminant validity, is it possible to measure all the heterorate, monotrate ratio, and then the Fornell-Lacker criteria and the cross-loading? All the three measures.
Yeah, if you have a perfect
or you
data,
can just pick one.
You can pick one, but the cross-loading should be the last thing you pick.
Okay.
You can pick one. But in case of a perfect data like this, you know, the lecturer's data is always perfect.
Yes.
Okay.
That I have a problem about that.
No, you can't have a problem about that. If you collect your data very well, there's a part where I discuss this in the next slide. If you've done your work very well on data collection, you pre-test your questionnaire, you review it with people who are knowledgeable in that field, and you consult literature while framing your questions, you would not face any problem. So you have problems in, remember what we are trying to do here is to check how reliable our data is. So when you have problems here, it means you've not designed your instrument well, it means you've not collected the data appropriately. So that can only be the problem. But if you've done your due diligence in data collection, you're not going to have any problem. And trust me, if you have a problem with all these things, you may have to go back to the field to collect the data.
Exactly.
So now,
can you please explain?
Okay.
Can you please explain it again, the cross-loadings?
Okay, the cross-loading is simply telling me that, you remember when we're forming our model, we said competency was measured by COMP1, COMP2, COMP3, isn't it?
Yeah.
So the cross-loading is telling me that because I have designed these three to measure this construct, the correlation between these indicators and this one should be very high. You can see they are high, 0.8, 0.8, 0.8. So they should only be high here. These variables here, indicators, should not have high correlations with the other construct here because I have not designed this COMP1 to measure loyalty. No. So I don't want to have a very high loadings here. So the highest loadings should be on the construct on which the indicators have been designed to measure. Similarly, if you look at customer loyalty, you can see that this is customer loyalty. You can see that the highest loadings are under customer loyalty, 0.85, 0.9, 0.8. And it is low on the other what construct. Does it make sense now?
Yes.
Do you understand?
Yes. And if,
okay.
And if the cross-loadings are in negative, they will be also considered low or in the negative direction?
In that case, we look at the absolute values.
Is this
and then if your
different?
cross-loadings are low, are negative, it means you should even delete those items from your okay, please, that's a very brilliant question. Let's go back. Let's go back to this diagram. That's a very brilliant question. Let's answer that question. You see, remember we said my items are designed to measure my construct, right? So imagine I'm having negative 0.8. It means there is an inverse relationship between my indicator and my construct. That means my indicator is not even measuring my construct, because the higher my indicator is, the lower my competence will be. So that variable should be deleted. If it's high, most time if it's very high, but I'm going to keep it simple. But in literature, there are conditions under which some negative, non-significant loadings can be retained. But if it's very high, the best option is to delete negatively loaded indicators. If it's high.
Very high will be.
Dr. Sam?
Yes, please.
Just a quick question based on what you said.
Minus 0.1 or minus 0.7, which is higher?
Sorry?
Between minus 0.7 and minus 0.1, which one is higher?
In absolute value terms, 0.7 is higher, because if in absolute value term, if one increment in the indicator will lead to 0.7 decline in my latent construct, then minus 0.7 is going to contribute more to the degradation of my model than minus 0.1. Do you get the logic? Do you get the logic? Because, we are not looking at it in that way, because we are looking at it as relationships. So if something reduces something by -1 and something that reduces by -7, which one is going to do more harm to my model? The higher one, right?
Yes.
Yeah, so that's the concept.
Someone
is asking another question.
Yeah, I also think maybe
Sorry,
to
I
also
can't
add
hear
up
you.
to what you said. I was saying that what your explanation to the correlation and question she asked, the correlation, we don't even consider the figures. The plus or negative tells you the relationship, either it is positive or negative. So like you said, it's the absolute number we take.
Yeah.
The minus just let you know it's negative relationship or positive relationship, but we'll take the
can you mute yourself, please? But in the case where you're having negative loadings, please check very well, because it could lead to problems in your discriminant and construct reliability calculation. So I would like us to take 5 minutes break or 10 minutes break. Then when we'll come back, we'll take it from
Hello,
here.
Doc. I think there are some hands up. If we can finish the question, like Joe, there's a hand up.
Okay, what's the question?
Yeah,
What's the
there's
question?
one question. Yeah, please finish your
Actually,
question.
data collection might be have a problem, but when the data is normal, and sometimes in statistics we have, for example, data standardization, log transformation, or normalization. Is there anything to do with this one in PLS?
That's a very beautiful question. As you said, okay, let me start with saying that we have two types of PLSM, that's the CBM and then the PLSM. Now, if you are running covariance-based structural equation modeling, then it is contingent upon you that your data should satisfy the assumptions of multivariate normality. But if you're doing partial least square, you don't need to satisfy those conditions. And so if, like yesterday, I did mention that CBSEM is actually aimed towards the validation of theories or hypotheses. So from the framework of your study, if your aim is to validate a theory or a hypothesis, it then means that you're likely going to use covariance-based structural equation modeling. And it means you have to ensure that your data, as you said, meet the requirement. And whatever you do to ensure that your data satisfies those requirements, you have to do them. But you have to make sure the data is okay before you perform the analysis. Does that answer your question, please?
Okay,
Hello?
so I think Cisse, your hand is up. So Cisse.
Yes, doctor.
Yes.
My question is, under the latent construct of competency,
yeah,
if they were under 0.7, how many factors should we maintain for analysis? Let's say, for example, if the three of them, the two were under 0.7, should we maintain the one which is above 0.7 and eliminate the two?
Thank you for the question. We don't just delete. There's something I still need to show us here. There's something else we need to consider, but I actually want to show us that after the brief, we don't just delete. As I mentioned earlier, while considering the quality criteria, remember, you can't delete two of them simultaneously. You have to delete them one after the other. And when you delete the first one, you have to go back to your construct reliability table and check if the deletion resulted in an increment on either the composite reliability or the average variance extracted. But when you delete and it doesn't increase it, and the factor loading is between 0.4 and just less than 0.7, it is advisable not to delete it. Do you understand, please? Hello?
Yeah, it's okay now. It's okay.
Do you get me, or you want me to explain again?
Yeah, it's understood.
Okay, thank you.
Okay, Doc, I have one question, then we'll wrap up for break.
Okay.
Yeah, so we've been looking at the data alongside the analysis. So I saw
The
a
noise at the
question.
background, I can't hear what you're saying, please.
I said, I saw a question in the chat box. Someone was asking if it is possible to use a secondary data. But then I don't know whether the person is referring to time series secondary data, so which I assume so. So can we do this analysis if our data is more of like a time series type of data or like a panel data?
Well, secondary data can be applied, but how the data is captured is very crucial. That is the framework. How is the data captured? Because secondary data is not necessarily time series data. A primary data can also be a secondary data. Do we know that?
Yes, please. So, like if it is time series.
If it is time series, you can, let's say you're measuring something like GDP. And you have said, okay, your GDP is going to be measured by certain variables. So it all depends on how you frame it, because the most important thing is you have to establish those relationships theoretically, that the construct you're forming can be measured with those underlying indicators. So if you have, let me say, GDP, and you want to measure it, maybe theoretically you've established that, okay, it can be measured by annual revenue, it can be measured by, so if theoretically you can establish that those are the indicators that measures GDP, and you structure the data accordingly, you can. But in that case, you're going to be considering a CBM-based model.
Okay, thank you so much. So, Doc, at this juncture, I think it will be okay if we take a 10-minute break and come back at 4:10.
Yeah.
Or you can get a cup of water to drink. So everyone, thank you so much. And it's a pleasure to have you here. We will take a short break. The link for yesterday's video is being made available. You can check from the chat box here. We'll post it also on WeChat. So have a good rest, and then we come back at 4:10. Bye.
All right, thank you.
Well, Kwame, your hand is up.
Okay, let me take it down. Sorry. Let's go. Okay, so
Kwame, you get question. You, doctor, you get question.
I'm just reading from the chat box for you. Me, I'm just asking from the chat box. People are putting it there. So don't worry, when they put that, I'll bring them to you. So
go on break, right? Convergent. Now that we've performed our convergent and discriminant validity test, the next thing to do is, remember, when you're writing your final output, you need to talk about this first. You need to tell us about your convergent value. That means you're assessing the measurement model. If your measurement model is not valid, you can't evaluate the structural model. So after running the convergent validity test, you've examined the factor loadings, the composite reliability, and then the average variance extracted. And you've also performed your discriminant analysis, and you've chosen any of the criteria. But please, as much as possible, try and stick to this or this. Try to avoid cross-loadings. Cross-loadings is very subjective. So to the best of your ability, try to use either the HTMT criterion or this, or the Fornell-Lacker criterion. It's more robust. So after doing this, because you're going to report all this before you go to your final hypothesis testing, you need to save this output. And the best way to save this output is to export it to Excel. So on my screen here, you can see there's an Excel logo there. So I'm just going to click. When you click it, it's going to show you something number format. Just leave it at the default setting and click export. And it's going to open a place for you to save. You can just save, and then it will render it and automatically save the output for you. Now, when you go to that output, let's go to that output. Okay, I think it's going to open. Let me share it. Did you want to open it? Yeah, open. I want to open it. No, this is not what I wanted. Okay, come on, let me go to where it is saved. I think it's saved in a SEM folder. Which one of the SEM folders? Is it here? Yeah. So wherever you've saved it on your computer, it will look like this. Please are you there? This is very important because you need this to write your final report after running the analysis. Have you been able to export it to Excel, please? Okay.
Can you
I think silence means consent. So I believe everyone has done that.
Could you repeat, please, this one saving?
Can you
go
please
back
repeat
to
it?
the,
Exporting to Excel.
can you see the Excel icon on your
Yes.
PLS? Just click on it. Have you clicked? If I clicked on it, it's going to open a pop-up window, and on it you can see Excel export, right? Can you all see
Yes.
that?
Yeah.
So just click export. When you click it, it's going to open a page for you to select where you want to save it. So you select a place you want to save it, and you click save. If I do that,
Yes.
it's going to tell me to replace because I've saved it already. So if I replaced it, you see, it's being used. So I've already opened it, so it's not going to save. So once you click on save, it's going to save it with the name of the project you're doing. Have you all saved?
Yes.
After saving, please go back to where you saved it. If it's not open automatically, go back to where you saved it and open the Excel sheet. If you've saved it and you've accessed it and you've opened it, you're going to have this output, this Excel output. Are we all there, please? If we are there, you can see path coefficient. If I go back to navigation, so I'm still going to go back and explain. So this is your result. I'm going to explain what the result is. Of course, you know what the discriminant and construct validity are. You know all this. So the essence of this is to show you how to export the output to Excel, where you can access it to write your final report. And probably tomorrow I'll show us how we write it in our thesis. So I'm going back to the PLS interface. So you've saved that. Now I want to show you something. You know, some people have this, should I use it on ethical habit in research? They need 500 sample size of data. Then they collect 200. Please, are you listening? They collect 200, then they copy and paste until they get 500. If you do that, your variance inflation factor is going to expose you.